time to fire up Stardew Valley. Let's see, crops look good, but I need rain. And the rain just seems to show up when it shows up, you know? Hey, a message from Stardew Master. What's this? If my character takes a specific number of steps just walking around, I can make it rain the day after tomorrow? I thought it was random.
If you've ever played a video game, you know how it goes. Whether you're looking for treasure in Minecraft or fighting enemies in Diablo, sometimes you find some great loot or knock out the final boss, and sometimes you don't. And then you see these speedrunners blasting through the game, getting all the best prizes and slaying all the bosses, and you wonder, how do they do it? Have they figured out some way to cheat? The answer probably lies more in their ability to assess the odds in ways that most casual players don't. And that means figuring out how these games use random number generators, which usually aren't that random. This episode of How Hacks Happen is the first in a series that explores the world of random number generators. As a way of easing into this technical subject, we're going to take a fun little romp through the world of random number generators for video games. Random number generators, or RNGs as they're called, are enormously important in cybersecurity because they're the basis for the encryption keys that protect our data, even in everyday use. When you access a website that has a little lock icon on the address bar, which most websites have these days, that little lock tells you that your communication with that website is encrypted, meaning no one else can see it. Encryption works with a key, a huge, long string of characters that you would need to decrypt that communication and see what's there. And this huge, long encryption key is randomly generated. The encryption algorithm shares that key only with your computer and the website. So whatever you're doing, a hacker can't pop onto the internet airwaves and listen in. But RNGs are also difficult to program in a way that will ensure true randomness. And when encryption keys are not as random could be, that means hackers can narrow down the choices or even guess them, which then means that you can get hacked. Players are able to hack video games because of weaknesses in their RNGs, which turn out to be some of the same techniques hackers use to exploit our everyday devices. But how is it that so-called random numbers aren't really random when a computer generates them? Well, we would not be how hacks happen if we did not know how this happens. Now, I'm not going to get super technical on you here in this episode. You know me, I want to make this understandable, simple as possible, without getting into the nitty-gritty of mathematical equations and such. I mean, I know you're listening while you're walking your dog or driving to work or reorganizing your kitchen cabinets or something. None of those are good times to get into heavy math. So I'll keep it simple, and we will all enjoy it a lot more. What I'm going to do is explain this concept of hackable keys in the context of something we can all have fun with, which use random numbers all the time. Video games. At least they're supposed to be random, but in reality they're, sometimes not. Many games use randomly generated numbers to mix it up a bit. These numbers determine things like how the environments are structured and where the loot is located and what kind of loot is there. Like, is it a loaf of bread or a big pile of gold? We're going to start with Minecraft, a game with hundreds of millions of players worldwide. In Minecraft, the goal is survival in a blocky world of hillsides and villages and loot chests where everything is made of blocks that you can break apart. So if you need wood, you punch a tree. And if you want some iron ore, you just find an iron mine and you punch it. Then you can build a house or a fortress from your wood and iron or whatever. You find these loot chests and you open them up and you hang out with other players and you trade the loot for weapons or food or whatever. Every once in a while, some monsters come and attack you, and hopefully you have a weapon handy. There's kind of an end goal, which is to fight the Ender Dragon, but if you want, you can just hang out in Minecraft for weeks and months and years and visit different landscapes and villages and never see the dragon at all. When you start a new Minecraft game, it's designed to feel like a random new world. The landscape, the trees, villages, the content of the loot chests, these are all randomly generated. And out in the world, we find these speedrunners blasting through the game. These are super fast players who somehow generate a specific kind of world where they can whiz through with all the best weapons and get to the dragon as quickly as possible and knock him out. These folks have figured out how to strip away the randomness so they know every move before it happens. And they do this by controlling the game's random number generator. And by controlling, I mean they know how to get a predictable world where they already know every nuance. So what is this random number generator in the context of games? Like, why is it even needed? Games rely on randomness to make it fun and challenging. If everything was the same every time, no one would want to play. Like, for example, take a game like Scrabble. Part of the fun is that you draw random tiles every time. If you drew the same tiles every time, it would get boring. In life, there are lots of random things, like who's in line in front of you at the grocery store, who would not be the person in front of you if you had spent 15 more seconds deciding which type of peanut butter you wanted, or if you had picked a different parking space and it took you 6 seconds more or less to get inside, or if you decided to skip the grocery store altogether and ordered a pizza instead. And the randomness of nature itself is pretty amazing. Why that craggy, rocky cliff formed in exactly the way it did, and why that one bump is there, and why that other part is smooth, is part of the practically infinite variations in the randomness of nature. A random number generator run by a computer program attempts to mimic this kind of randomness found in the human experience or the forces of nature. But it can never quite get there because computers aren't random in any way. Computers do what programmers tell them to do, and everything runs on numbers. At any given time, the choices are 1, 2, 3, 4, and so on. So how do you make a computer make random decisions? This is a question that has challenged programmers and systems engineers for decades, and still does to this day. The best answer is to find something that's kind of random already, and base your calculation of the random number off something like that. Like a classic one is the clock time on a computer, when the user presses a particular button. This is what a lot of early video games did. In your computer, there's a clock that's constantly running. It's got hours, minutes, seconds, milliseconds, and it just runs and runs and runs. When you save a file, this is how it gets the date and time. It's right there in the clock that is always running. So in this scenario, using the clock to make a random number, the numbers on the time clock make up the seed, the number that gets fed into the random number generator's algorithm to produce a supposedly random number. Like the RNG might take the seed and multiply it by some specific huge prime number, then divide it by some other prime number, and use the remainder as the so-called random number. This is what's called a pseudo-random number generator, or PRNG. It gets its randomness from known predictable data like a time clock, or the number of frames between when the user started up the game and when they pressed play. Like if a game runs at 60 frames per second, it's got its own clock counting the number of frames between different incidents. And because this PRNG uses the same algorithm every time, any one seed produces the same random number every time. This type of RNG is called deterministic. That's a little technical term there, because the output is repeatable based on a predictable seed. So this term deterministic basically means repeatable and predictable. And when a random number is repeatable, players, and also hackers, are not far behind trying to figure out the pattern so they can predict what it will be. A lot of early games, like Nintendo games in the 1980s and 90s, used RNGs in this way, with the clock data as the seed for the random number generator. This type of randomness works out fine for someone who just wants to play, but speedrunners are always looking for a hack, and they sure found them. For example, a speedrunner might figure out that if they wait exactly 6 seconds between firing up the game and pressing play, they get a specific environment with the best loot and weapons. It might be tricky to press play right at the exact right moment, but if they try it often enough, they'll get it. And then, of course, they got a little bragging going on. They post this hack on a games forum, and then the entire world knows. These types of RNGs with a seed based on the computer's clock are so easy to crack that most games have stopped using just the time by itself. Instead, they add some other random data to get a very long seed number, and they feed that into the RNG to get another random number. This is how Minecraft does it. In Minecraft, you can actually enter your own seed number, or the game can generate one for you. And if you use the same seed over and over, you'll get exactly the same landscape over and over. As for the loot in the chests, what's in there depends on the seed, plus the location of the loot in XY coordinates and some other limited and fixed information that you can figure out through repeated gameplay. So you can eventually know ahead of time what kind of loot is in each chest. This gives players the ability to work through the same scenario over and over, with the same landscape and loot chests. It's kind of like the movie Groundhog Day, where Bill Murray gets the chance to try 1,000 different variations on the same day until he gets the outcome that he was headed for all along. This might seem to make Minecraft boring, but for many players, it doesn't. For lots of them, exploring the landscape and the loot is the most fun way to play the game, not speedrunning. If you want to try a particular type of environment, there are lists upon lists of Minecraft seeds readily available on YouTube and everywhere else on the internet. Seeds that you can use anytime to generate a world with lots of rivers or hills or temples or whatever it is that you want. Oh, and it turns out that there are seeds that will produce the perfect game for speedrunning. A combination of loot chests full of iron and other metals right in front of you, and nearby villages with blacksmiths who can forge weapons for you. And knowing how to hack the RNG that determines the loot in each chest, you can blast right through and slay that dragon. Minecraft has had this put in your own seed feature almost from the beginning, starting in 2011. For the Minecraft player base, this seems to be the perfect way to go about it. So in this way, Minecraft isn't really so random anymore. I mean, it is, but since it's easy for anyone to find the seed they want to get the result they want, it kind of took the random out of the randomness. But hundreds of millions of players don't seem to care. They're getting their own randomness out of exploration and interacting with other players and constructing new things and just having a good time. This is similar to the way seeds and RNGs used to work in Stardew Valley, the game mentioned at the top of the episode, where players manage a farm and engage in gentle interactions with other characters, like going to visit the plant lady to pick up some herbs to fertilize your crops. And there's no dragons, there's no invading hordes of zombies, there's just farming. Play sessions are divided into days, and in earlier versions of the game, the number of steps your character took in any one day as it went around to feed the pigs or buy seeds or whatever became part of the, quote, random number that determined things like the weather and your luck value for the next few days. Another little hack was to dig around on your farm and find clay, which is valuable in the game. And then you could take a set number of steps to the right and set number of steps in this other direction. And right there you would find more clay. And you could repeat and repeat this step movement to find all the clay in your field. The randomness was just, one step this way, 3 steps that way. These are examples of a pretty lazy RNG development. But Stardew Valley is a really laid-back game, and I can't say I fault the developers for it. It's hard to randomize everything, and none of Stardew Valley's millions of players seem to mind either. I tell you all this not to diss on the RNG developers for these games, but to point out how hard it is to make something that's not random seem to be random, and how sometimes it's more sensible to just give up on it altogether and let people make their own randomness, whether by entering a seed or moving around the game in a certain way. To get another perspective on random number generators in games, let's take a look at another game, Diablo II. Diablo II is an action game set in a fictional kingdom where players control a lone hero with the goal of defeating Diablo, the Lord of Terror. The player travels through different randomly generated environments, fighting off enemies and gathering loot, until they eventually reach the final level of Hell to face off with the final boss, Diablo. Diablo II was released in 2000, and players quickly found that there was an internal seed set at the start of the game that controlled everything: the environments, the enemies, the loot, and even aspects of the fight with the final boss. People played the game locally on their own PCs, and when they saved a game, the seed itself was saved locally too. So when the player loaded up the game again, the same seed would generate the same environments and everything else, and the player could pick up where they left off. But this also meant they could poke around in the saved file and find the actual seed value. With the seed readily discoverable like that, some players just couldn't help doing their own deep dives and taking advantage of it. Some players even poked around in their own PC's memory to pick up on the logic being used to generate the seed and find out how the seed affected seemingly random events like how many enemies would appear and how many hits they'd need to defeat them. All kinds of reverse engineering tools started appearing on gameplay forums, and players spent endless hours figuring out how to ensure a, quote, good seed so they could get to the end and defeat the final boss. The creator of the game, Blizzard Entertainment, took notice, and when Diablo III and IV were released, this loophole went away. These newer games are played entirely online, so the seed is stored on the game's servers, not locally. There's also some speculation that the operation of the random number generator for Diablo 3 and 4 changes from one player to the next, and if that's true, there's no hope of players ever reverse engineering it. The approach that Blizzard took, keeping the seed private and secret, and possibly changing the RNG algorithm from time to time, is the opposite to the approach Minecraft took of just handing over control of the seed to players. But there's a trade-off. While you can play Minecraft locally with your known seed stored locally on your PC, you have to play Diablo 3 and 4 only online. This might not seem like a big deal since most of us can get online anytime we want, but it is an example of different approaches to seed management. I hope these examples make it clear that not all random number generators are created equally. These different approaches give us a good framework for looking at how different companies handle their encryption keys for cybersecurity. But that's for the next episode. Well, I did not lie to myself. That was fun. Learning about random number generators in games. Maybe you can use these principles to have more fun when you play your favorite game, or to achieve your lifelong dream of becoming a speedrunner. How you use it is up to you. But this business of random numbers, it's not always fun and games. In the next episode, you'll learn how RNGs are serious business when it comes to cybersecurity, and how they don't always put the odds in your favor. This is Michelle Bousquet, signing off. See you next time on How Hacks Happen. And if you want to learn more about how random number generators work, there's a whole chapter on them in the book, The Art and Math of Cryptography, available at Amazon.com.